Graph linear equalities in two variables. A linear inequality in two variables is a function in the form some number times x plus another number times y. And instead of an equals here, we're going to have some sort of inequality. So we can choose to put greater than, or we could put less than, or greater than, less than or equal to, or greater than or equal to, and then some number c. The solution of a linear inequality is an ordered pair that makes the inequality true. To graph a linear inequality is we need to, on the coordinate plane, show every ordered pair that's a solution. Half plane, just leave blank. Okay, checking solutions. To check a solution to an ordered pair, I just need to put the ordered pair inside the equation and see if they're true. So 4 times x, where's my x here? So my x is 3, plus 2 times y, so my y is 2. That's 12 plus 4, and 12 plus 4 is 16. Is 16 greater than 6? Yes. So this point is a solution. Let's try it for this point. If we put in -1 and 4, I will get -4 plus 8. And that equals +4. Is +4 greater than 6? No. So this point is not a solution. Checkpoint. Go ahead and substitute your points into this equation and see whether the equation is true or not. Graphing a linear inequality. To graph these, you graph the boundary line for the inequality. And we're going to use a dashed line for less than or greater than, and a solid line for greater than and equal to, or less than and equal to. Then we're going to pick any point that we want and test that point to see whether it's, and it needs to be not on the boundary line, but then we determine whether it's a solution of the inequality. If it is a solution, shade the half plane containing the point. If it is not a solution, shade the other side of the half plane. So we're going to graph this. Graph the boundary line y equals -1. And then we're going to use a dashed line. Okay, so to graph this, I'm going to say y equals -1. So no matter what x I put in, y is always going to be -1. And I'm going to use that dashed line because we're just using the less than sign. Now I'm going to use a test point 0, 0 to decide which side to color on. And we're going to test this and use this point because it's just a nice convenient point to put in. So I'm going to stick in 0 when I see an x and 0 when I see a y in my line. So y, so 0 is less than -1. Is that true? Yes. No, that's not true. So we're going to shade the half plane that does not contain the line, or the point 0, 0. Right? Okay, example 3. I'm going to graph this in a coordinate plane. I'm going to think about this inequality as being an equal sign. I'm going to graph that line. So, if I stick in a 0 for x, what do I get out for y? Then I will have negative 2y equals negative 6 divided by negative 2. I'll have y equals positive 3. Now I need one more point to graph the line. So if I put in a 0 for y, I'll have 3x equals negative 6 divided by 3. And I'll have negative 2 for x. So I'm going to graph these 2 points. Negative 2, 0, and 3, 0. Now, I need to use a dashed line because it's a plain less than sign, not less than or equal to. So I'm going to draw through here with dash. I'm going to pick a convenient point, and 0, 0 is always a convenient point as long as it's not on the boundary line. So if I put in 3 times 0 minus 2 times 0, is it less than negative 6? So 0 minus 0, is 0 less than negative 6? No. So it is not a solution. So I don't want to shade the side that contains 0, 0. I want to shade the side that does not contain 0, 0. Example 4, graphing an absolute value inequality. So I need to graph that, again, just like there was an equal sign here instead of a greater than sign. So I can pull off the h and k. This sign needs to be the negative, so my h is positive 1. This sign needs to be positive, so my k is positive 2. That's my vertex. So 1, 2. Now, I need to pick another point to show where my v would be. So let's pick 0 for x. So y equals negative 3 times 0 minus 1 plus 2. Y equals negative 3. The absolute value of 0 minus 1 would be positive 1 plus 2. Negative 3 plus 2 is negative 1. So if I put in a 0 for x, I get a negative 1 for y. And then I know to do my mirror image, so I can come down to this side and continue my line. Now, I need to look at the boundary line. This needs to be a dashed line. I'll use my eraser and dash it out. And now I need to pick a test point. And 0, 0, it kind of looks like it, but 0, 0 is not quite on that point. But if I was graphing this on a test, I would say, maybe 0, 0 is on that point. So let me go ahead and pick another point that I know for sure is not on that boundary line. So how about negative 1, 0? Okay. Now, I'm going to put in 0 for my y, and negative 1 for my x, and see if that's true. So 0 is less than or greater than -3. The absolute value of -1 minus 1, -1 minus 1 is -2. Absolute value is +2 plus 2. So that's -6 plus 2, which would be -4. Is 0 greater than -4? Yes. So I need to graph the side that had my test point of -1, 0 on it. And this time it's just not a side, it's the whole area outside that V shape. Okay, checkpoint. Go ahead and graph these. Remember to graph the boundary line first by taking out the inequality and just graphing the line with an equal sign. Make sure on 3 that the line that you graph will be a dashed line. 4 will be a solid line. 5 will be a dashed line. And 6 will be a solid line. Okay. In fact, 6 is a V since it's an absolute value.